Hello students, welcome back. Let's take up another sample paper question, and this question is of 5 marks. The question is from electricity chapter and the question reads, the arrangements of resistors shown in the above figure is connected to a battery. The power dissipation in the 100 ohm resistor is 81 watt. Calculate the current in the circuit, the reading in the voltmeter V2 and the reading in the voltmeter V1. Alright, so here we have been given a circuit in which there are two resistors of 25 ohm which are connected in parallel to a 100 ohm resistor which is connected in series. There is a voltmeter V2 which is connected across this parallel combination in this branch. There is another voltmeter V1 which measures the potential difference across the circuit. So let's solve it and find out the answers to the question that are asked. Now to find out the current in the circuit, the resistance is given as 100 ohm and the power is given as 81 watt. Now we know the formula, power is equal to I square R. So this is the formula connecting power, current and resistance. So current will be I is equal to P by R whole under root. So power is given as 81 and the resistance is given as 100. So it is under root of 81 by 100, which is 9 by 10, that is 0.9 ampere. Hence the current through this 100 ohm resistor I is equal to 0.9 ampere. Now this current of 0.9 ampere will pass through this circuit. So the current in the entire circuit is 0.9 ampere. So this is the answer to the first bit question. Now the second bit asks to find out the reading of the voltmeter V2. Now this voltmeter V2 measures the voltage across the two resistors of 25 ohm each that are connected in parallel. Now we know the value of current that is entering this combination of the parallel resistors of 25 ohm each. So in order to measure the potential difference V2, we have to find out the equivalent resistance of this parallel combination first, and then we'll apply Ohm's law to find out the potential difference V2. So let's find out the equivalent resistance of this branch. So Rp is equal to R by N. Now R value is 25 ohm and N is the number of resistor, that is 2 in number. So it is 25 by 2 or it is 12.5 ohm. So if you are wondering where did I get this formula from, please watch this video of mine to understand more about this in detail. So the equivalent resistance in parallel is 12.5 ohm and the current that is passing through this equivalent resistance is 0.9 ampere. According to Ohm's law, V is equal to IR. So here it is V2. So V2 is equal to I into R parallel. The value of I is 0.9 and the value of equivalent resistance is 12.5. Hence the reading of the voltmeter V2 is 11.25 volt. So this is the answer to the second bit, that the potential difference V2 is equal to 11.25 volt. So this is the answer to the second bit. Now the third bit asks the reading of the voltmeter V1. Now voltmeter V1 measures the total voltage supplied by the battery, which is the sum of the potential difference or the voltage across this 100 ohm resistor and the potential difference across the equivalent resistance of this two parallel combination, that is V2. So if we add V100 and V2, we'll get the total potential difference of this circuit, that is V1. Now let's find out the potential difference across the 100 ohm resistor. So V100 is equal to I into R100. I value, that is the total current flowing in the circuit. Here we got it as 0.9 ampere multiplied by the resistance, that is 100 ohm. So the voltage across the 100 ohm resistor is 90 volt. So here I write V100 is 90 volt. Therefore, the total potential difference V1 is the sum of the potential difference across the 100 ohm resistor plus the potential difference V2. So V100 we got it as 90 and V2 we got it as 11.25. So it is 101.25 volt. Hence V1 is 101.25 volt. You can either do it in this way or there is another way in which you can find. Now if we find out the total resistance of the circuit, applying Ohm's law, we can find out. So our total will be resistance of 100 ohm plus the equivalent resistance of the parallel circuit. So 100 ohm resistance value is 100 plus the equivalent resistance we got is 12.5. So the total resistance in the circuit is 112.5 ohm. Now the current flowing in the circuit is 0.9 ampere. Hence applying Ohm's law, V1 is equal to I into R total. So I value is 0.9 multiplied by the total resistance is 112.5 ohm. So the total potential difference V1 comes to be 101.25 volt. So this is another way in which you can find out the total potential difference in the circuit. So either you can do it in this way or in this alternate way and find out the value of the potential difference of the circuit. So I hope you have understood the solution to this. If you found this video helpful, please do like this video because your like motivates me to make more such videos for you. And if you are new to this channel, request you all to please consider subscribing it. So that's all in this video. See you in the next one. Thanks for watching.